video, we are going to see about exam number 4, matrix addition with unified memory. So our aim is to perform matrix addition using QDAR unified memory. First, to compare performance with and without MEMSET using profiling tools like NVProf and NVP. So we are going to set up the procedure. So first, set up GPU device. Select CUDA device, display device name and properties. Next, set matrix size. So use set matrix dimension, then compute the total elements and bytes. Now allocate the memory allocation. Use CUDA malloc manage to allocate unified memory for A, B, host reference and GPU reference. Now initialize the input matrices. Use initial data to fill matrices A and B with random values. Then record installation time. Now host computation. Perform matrix addition on CPU using sum matrix on host. Measure host execution time. Now warm up the kernel. Launch small dummy kernel to migrate unified memory pages to GPU. Now launch the GPU kernel. Configure grid and block dimension. Run sum matrix GPU for actual matrix addition. Synchronize and measure kernel execution time. Now check the result. Compare GPU results with CPU result using check results. Now the performance being compared. So run once with MEMSET. Run once without MEMSET. Observe the time difference, very small. It around 0.00 second, 001 second. Now clean up the memory using a CUDA free. Now reset the device. So now we going to see about program. Now we have to allocate that header file and macro studio.h CUDA runtime.h. Next macro check CUDA error for every API call. Then second, return current time for timing operation. Now initialize data. So using a void initial data. Then use sum matrix on host. Use CPU code, add matrices row wise. Now check the result. Compare CPU result, host reference with GPU result, GPU reference. Check floating point difference with small epsilon. Then GPU kernel, global void sum matrix GPU. Each thread computes IX, X index of the thread, IY, Y index of the thread. IDX is equal to IY into NX plus IX. Only valid thread inside matrix bounds will write. Then main execution flow. Now select GPU, then set matrix size, then allocate unified memory. After matrix initialization, then clear output arrays. Now do matrix CPU matrix addition and then configure CUDA grid, then warm up kernel and then verify result. Now free the memory. So unified memory warm up already migrates. GPU kernel rewrite every element of GPU reference. Host reference MEMSET is irrelevant because CPU overrides it fully. So removing MEMSET changes time only by 1 microsecond.